Welcome to the Deep Dive. Today we're embarking on a mission that's, well, becoming increasingly vital for pretty much anyone navigating the modern professional world, especially if you're in the legal field.
Absolutely.
Artificial
Yeah.
intelligence. It isn't just some buzzword anymore, is it? It's this rapidly evolving force, and it's fundamentally reshaping industries, processes, and definitely how legal professionals approach their work. Okay, let's unpack this. We're going to try and cut through some of the noise today, equip you with the precise terminology and insights you really need to understand AI's impact.
What's fascinating here is just, the sheer speed of change. It's incredible.
Right.
And without a solid, maybe nuanced grasp of the foundational language, it's incredibly easy to get lost, just overwhelmed by all the information, the marketing claims.
Yeah, hype.
Exactly, the hype. So this deep dive, it isn't just about reciting definitions. It's about giving you a clearer mental map, helping you separate what's genuinely capable from what's just hype, and also assess the real risks. Critically evaluate the promises you hear. Our insights today, they're primarily drawn from a really excellent resource, the Complete Legal AI Glossary by Jean Gahn.
Yeah.
It provides a very strong foundation for these kinds of discussions.
Exactly. Think of this as your essential shortcut to being genuinely well-informed. So you can engage with AI on a deeper level. We'll explore these core AI foundations, get into their precise meanings, understand their critical and often complex implications,
Mm.
and ground everything with real-world, practical examples, stuff to make these concepts actually stick.
Yeah.
Our goal is really to empower you to ask the right questions, spot those subtle but significant differences that really matter. So let's jump right in. So when we talk about AI, it just feels like this massive, almost all-encompassing concept.
Uh-huh.
Where do we even begin? How should we define artificial intelligence itself? What's the kind of working definition we should be using?
Yeah, it's a big one. I think instead of just saying mimicking human intelligence, which is common for legal professionals, it might be more productive to see it as let's say, a spectrum, a
Yeah.
spectrum of advanced computational systems. These systems are designed to do tasks that traditionally need human cognitive abilities, reasoning, problem solving, learning from data, adapting.
Okay.
So the key isn't just knowing what it is, but maybe understanding where it begins and ends in a practical legal sense, especially when you're trying to distinguish, like you said, genuine capabilities from vendor hype.
Ah,
Because often what gets marketed as AI might just be very sophisticated automation, but not truly learning or adapting.
right. That distinction feels absolutely crucial because you might encounter, say, a startup claiming its compliance system is AI-powered. Sounds impressive.
Mhm.
But after you do some proper due diligence, you might find out it's actually just a really complex rules-based expert system.
Mm.
It follows rules, but it doesn't learn in the way AI sort of implies.
Exactly.
And that difference can completely change how you advise a client or maybe assess a potential investment, can it?
Completely. It changes the risk profile, the expectations, everything.
So, okay, for those systems that do actually learn that truly intelligent part, the core question then becomes how? How do they achieve that learning capability? This feels like the next layer we need to peel back.
That's precisely where machine learning, or ML, comes into the picture. ML is a fundamental subset of AI. It describes algorithms that learn directly from data patterns. So instead of being explicitly programmed for every single possible task, they figure it out from the data. It's about statistical inference, pattern recognition,
Right.
and its relevance in the legal world is huge. We see it in tools for HR compliance, financial fraud detection, even predictive analytics for case outcomes. But here's where it gets tricky. Beyond just the liability, if the outcomes are biased, which is a big issue, the real challenge for legal professionals often lies in the auditability of these systems.
Auditability. How so?
Well, unlike traditional software where you can maybe read the code to find a bug or bias, with ML, it's often not that simple. You might need to analyze the training data, the model's outputs, its behavior, and that often bumps up against issues like vendor IP or data privacy. It's a legal gray area.
That auditability issue is fascinating. So it's not just if bias exists, but how you even prove it in the first place. And then, yeah, who's responsible? And we've definitely seen real-world consequences, like an ML-powered recruitment tool that systematically, even if it wasn't intended, excludes older applicants based on patterns it learned.
Yes, those cases are emerging.
That immediately raises questions, doesn't it? Is the algorithm just reflecting biases already in society, or is it creating new ones? And that leads directly to discrimination claims. How do you even start to litigate that without transparency into the model itself?
It's a massive challenge for the legal system.
Okay, so if ML is about learning from data generally, what about the more advanced methods? We hear a lot about deep learning these days. How does that fit in?
Right, deep learning, it essentially takes machine learning a step further. It's a specific subset that uses something called neural networks, and these networks have many layers, hence deep layers.
Yeah.
This structure allows them to process incredibly complex, sort of hierarchical patterns in data, much more complex than traditional ML sometimes. This makes it really effective in areas like advanced evidence analysis, think sophisticated handwriting authentication, or forensic facial recognition, or even spotting subtle patterns in huge document sets.
Powerful stuff.
Very powerful. But, and this is a big but for legal uses, its power often comes with a significant drawback: a lack of explainability.
Explainability.
Yeah. These models can arrive at highly accurate conclusions, but they often can't articulate how they got there. It creates this black box problem. We know the input, we know the output, but the process in the middle is opaque.
Wow, that lack of explainability sounds like a huge deal in legal contexts. I mean, the whole legal system is built on transparency, precedent, showing your reasoning. Yeah. So if a system can't explain its reasoning, how does that impact fundamental legal principles like due process or the right to a fair hearing? Are we already seeing defense lawyers challenging things like deep learning-based facial recognition in trials precisely because the system can't explain itself?
Yes, those challenges are happening. It clashes fundamentally with how courts need to operate, understanding the basis for evidence and decisions.
So you mentioned the architecture behind this black box issue is often these neural networks. What exactly are these?
Right. Neural networks, at their core, they're mathematical models. They're inspired by the structure and function of the human brain, with interconnected nodes, sometimes called neurons, that process information in layers.
Inspired by the brain.
Okay, they are absolutely central to almost all modern AI, especially deep learning. And the key thing for legal professionals to grasp is that, as we said, they often function as black boxes. Their decision-making process is incredibly complex and opaque. It makes their internal workings exceptionally difficult to interpret, even sometimes for the engineers who built them.
A black box making decisions. That raises serious questions, especially when people's livelihoods or, even liberties are on the line. You could imagine a scenario, maybe a financial regulator demands an insurer explain exactly why its AI denied a bunch of claims.
Right.
But the company just can't. They can't fully interpret the neural network's complex, multi-layered reasoning. That's a massive problem, isn't it? Not just for accountability, but for regulatory compliance, public trust.
It undermines trust significantly if decisions can't be explained or appealed effectively.
Okay, let's shift gears a bit. Let's talk about something that has really captured the public imagination recently, and it's shaking up pretty much every industry. Generative AI. Gen AI, this feels like a real game changer.
Oh, absolutely. Generative AI is a particularly potent form of AI. It doesn't just analyze or predict data. It actually creates entirely new content. Yeah, creates this. This could be anything from text that sounds human-written to images, audio, video, even 3D models or computer code. It's the core tech behind wildly popular tools like ChatGPT, Midjourney for images, and also the increasingly sophisticated legal drafting tools that are popping up.
Right.
But its power comes with equally critical issues that lawyers especially need to grapple with. Things like potential breaches of confidentiality if sensitive data is input, complex intellectual property questions, who owns the output, what if it learned from copyrighted material, and crucially, the ever-present risk of inaccuracy, or what we sometimes call hallucinations.
Hallucinations.
Yeah.
We'll come back to that.
Yeah.
But those confidentiality and IP issues are huge. On IP, are we seeing new kinds of disputes about the ownership of the AI-generated stuff itself? Not just if it copied something, but if it creates something genuinely new, who owns that?
That's a cutting-edge legal question right now. The law is still catching up. Does the AI get authorship? Does the user who prompted it? The company that trained it? It's complex.
And we've already seen real-world examples, haven't we? Like a law firm using Gen AI to help draft a client memo maybe speeds things up, but then they find sections of it were inadvertently plagiarized from existing published work because the AI scraped it during training. That's an ethical nightmare.
A huge professional minefield. It underscores the need for careful review and understanding of the tool's limitations.
So within this generative AI space, We hear the term large language models, or LLMs, all the time. They seem to be the engine behind a lot of the text generation we're seeing.
Yeah.
What makes them tick, and what are their specific pitfalls?
You're spot on. LLMs are a specialized type of generative AI. They're trained on truly vast data sets of text, think like huge chunks of the internet, books, articles, trillions of words.
Wow.
And this massive training allows them to understand, summarize, translate, and generate remarkably human-like responses. Lawyers are definitely starting to use them for drafting initial documents, maybe doing preliminary research, summarizing depositions, even brainstorming arguments. However, and this is the big one, the most significant risk with LLMs is their tendency to hallucinate.
There's that word again. What does it mean in this context?
It means the LLM generates information that sounds perfectly plausible, maybe even authoritative, uses the right jargon, but it's completely false, made up, fabricated.
Made up.
Yes. And it's not really a bug that can be easily fixed. It's more like a fundamental characteristic of how they predict the next word based on probabilities. They don't know if things are true. They know what sounds like a likely continuation of the text. This poses immense dangers in legal settings where accuracy is absolutely paramount.
Hallucinations in a legal context.
Yeah,
The stakes couldn't be higher. You could have an LLM cite a completely non-existent court case in a legal brief.
it has happened, famously so.
Or make up a statute section. That's not just a minor error. You could torpedo legal advice, lead to flawed arguments, maybe even court sanctions. What are people doing to try and catch these? How do you prevent that kind of critical inaccuracy before it causes real damage?
It requires rigorous human oversight, fact-checking every single output, cross-referencing with reliable sources, and, frankly, understanding that these tools are assistants, not replacements for legal judgment and verification.
Right. Human in the loop is critical. So LLMs generate text.
Yeah.
But stepping back a bit, for AI to understand our language more generally, not just generate it, there's a broader field involved, right?
Yeah.
How does AI actually get the nuances of human language?
That brings us neatly to natural language processing, or NLP. NLP is the sort of overarching field of AI that's dedicated to enabling computers to process, analyze, understand, and also generate human language.
Okay, so it's broader than just LLMs.
Yes, much broader. It's absolutely foundational to so many legal tech tools you might encounter. It underpins advanced e-discovery platforms that sift through millions of documents, got contract review systems designed to extract key clauses, even sentiment analysis tools trying to gauge tone in communications. The challenge, though, and the sort of hidden risk, is that even quite subtle misinterpretations by an NLP system can lead to incredibly costly errors in these vital legal processes. It could derail a case or create significant unforeseen liability.
Misinterpretation.
Yeah.
Yeah, it can be subtle but devastating. I can imagine an NLP system looking at contracts and misclassifying a termination for convenience clause, which is often fairly neutral, as a termination for cause, which implies wrongdoing.
Exactly. Those are two vastly different legal concepts with hugely different consequences for damages, remedies, reputation.
So how do legal teams effectively audit or validate the NLP's understanding to make sure critical errors like that aren't slipping through the cracks, especially when dealing with high volumes of documents?
It involves careful system calibration, testing with known examples, having humans review borderline or ambiguous cases, and understanding the specific limitations of the NLP tool being used for that particular task. It's not plug and play.
Makes sense. This discussion about LLMs and NLP, it leads to a more technical question, I suppose. You mentioned the power of recent models.
Yeah.
What's the secret sauce? What was the architectural breakthrough that enabled all this?
The secret sauce. For a lot of the recent progress, particularly in language, it's something called the transformer architecture.
Transformer architecture.
Yeah, it's a specific deep learning model design that came out around 2017. And it fundamentally enabled the breakthroughs we've seen in large language models and many other natural language tasks since then. It uses a mechanism called attention, which allows it to weigh the importance of different words in a sequence when processing context. This makes it incredibly good at understanding long-range dependencies in text.
Okay. Attention.
It's really the fundamental basis of today's AI boom, especially in language understanding and generation. And for legal professionals, understanding its significance becomes relevant in areas like, say, patent law and intellectual property disputes.
How so?
Well, you might be examining claims around new AI technologies or assessing potential infringement. Knowing about the transformer architecture helps you understand if a new system is truly novel, or if it builds on existing, perhaps patented techniques.
Right. This is where understanding the technical backbone really becomes critical for legal strategy, maybe even for commercial advantage. You could easily see a patent case hinging entirely on whether a new system based on transformers infringes on older algorithms or IP rights,
Mhm.
or if a competitor system is using a protected aspect of this architecture.
Absolutely. It means lawyers increasingly need to be comfortable, at least conceptually, with these engineering ideas.
Okay, so if the transformer architecture helps AI understand context and relationships between words, how does the AI actually read or represent the meaning of individual words or phrases? Not just the letters, but the concept behind them. This is where embeddings come in, isn't it?
Exactly right. Embeddings. These are essentially numeric representations. Think long lists of numbers, vectors that capture the semantic meaning of text, or other types of data, too.
Numbers represent meaning.
Sort of. In this high-dimensional mathematical space created by the embeddings, words or concepts with similar meanings end up being located closer together. King might be close to queen, royalty, maybe even power.
Okay, I think I get it.
They are absolutely crucial for sophisticated legal search engines, knowledge management systems, even for clustering similar documents together automatically. But, and here's the catch, the quality of these embeddings is paramount. If they're poorly constructed or maybe reflect biases in the training data, they can cause crucial information to be missed or incorrectly grouped. This leads to incomplete or inaccurate search results.
Missing crucial information just because of how meaning got translated into numbers, that's a very real practical concern for lawyers.
Definitely.
Imagine like a sanction screening tool. It might fail to link two slightly different spellings or aliases for the same sanctioned person or company if the embeddings aren't good enough to see they're related.
A classic example.
Or a legal research tool missing a really relevant case because its embedding system didn't quite grasp the conceptual similarity between two different legal phrases used. That's a huge compliance risk. Or a litigation disadvantage really highlights the need for careful data curation when
Yeah.
building these things.
Precisely. Garbage in, garbage out applies just as much to embeddings.
So if we have these embeddings, these meaning representations in numbers,
Yeah.
where do they actually live? How are they stored and managed so efficiently? What's the infrastructure?
That takes us to vector databases. These are specialized databases. They're specifically designed to store, index, and, crucially, efficiently retrieve those high-dimensional embeddings we were just talking about.
Specialized for vectors, okay.
Traditional databases are good for structured data, like tables. Vector databases are optimized for finding vectors, embeddings that are close to a query vector in that high-dimensional space. They're increasingly being used in legal knowledge management systems. They power more intelligent semantic searching by meaning, not just keywords across legal documents, expert witness materials, internal memos, precedents.
Sounds useful.
Very. However, because they're often dealing with potentially highly sensitive client confidential information but stored and indexed in this new way, there are inherent confidentiality and data security risks. These absolutely must be meticulously managed with robust safeguards and strict access controls.
Confidentiality.
Yeah.
Always paramount in legal work, probably the single most important ethical duty.
Absolutely.
And you can see the risk. We've heard anecdotes, maybe hypothetical, maybe real, of firms uploading vast quantities of client memos into a vector database for internal knowledge sharing. But if the safeguards are weak, that creates a huge potential attack surface for leaks of incredibly sensitive information. It really hammers home the point. You need to understand the underlying tech, not just the shiny benefits, and implement top-notch security.
Couldn't agree more. Security and governance have to be front and center with these systems.
Okay, stepping back even further, almost to the very beginning of how AI handles text. Before it can even do embeddings or understand context, it has to break the raw text down into pieces it can work with, right? That seems like a fundamental first step. What's that called?
Precisely. That fundamental process is called tokenization. It's simply the method of splitting raw text, like a sentence or a document, into smaller, discrete units.
Units like words.
Often words, yes, but sometimes it can be subwords, especially for handling variations or unknown words, or occasionally even individual characters. These units are the tokens that the AI model actually processes.
Okay, tokens.
And the specific way a text is tokenized isn't just some minor technical detail. It directly sets practical limits on the amount of information an AI can handle in one go. This is super critical when you're dealing with very long documents, lengthy contracts, huge case files, extensive email chains, and e-discovery.
Wait, so how the text is chopped up can actually limit what the AI can even understand. That's counterintuitive, but makes
It
sense.
does.
So you could have, say, an incredibly long and complex commercial agreement. If the AI hits its token limit during processing, it might just stop. It might cut off mid-sentence or mid-clause.
Exactly. It means it literally never sees the full context or the complete picture of a critical provision. If that provision falls beyond the token limit, it can process at that moment.
Wow. How do practitioners deal with that? How do you work around those inherent tokenization limits when reviewing massive legal documents? Are there strategies?
There are strategies like breaking documents into overlapping chunks, summarizing sections first, or using models specifically designed for longer inputs, but it requires careful implementation.
Okay, that leads directly to the next point.
Yeah.
Building on tokenization, once the text is broken down into tokens, how much of that tokenized text can the AI actually see and process at any single moment? You mentioned limits. This sounds like another really practical constraint.
It absolutely is. And that concept is the context window. The context window refers to the maximum length of text measured in tokens that a particular AI model can process or consider at any single time.
It's working memory almost.
That's a great way to put it. It dictates how much information the AI can hold in its focus while it's generating a response, analyzing content, or making a decision based on the input. And this is an absolutely critical limitation when you're reviewing long, complex documents. Think lengthy merger agreements, massive litigation discovery files,
Yeah.
because any information, any clause, any fact that falls outside that specific context window is by definition simply ignored by the model for that specific processing task. It doesn't know it exists if it can't see it right then.
This sounds like it could lead to huge, potentially catastrophic oversights in legal analysis. Easily.
Mm-hmm.
You could have key arbitration clauses, maybe crucial liability limitations, essential definitions, or force majeure provisions just missed entirely because they happen to fall outside the AI's context window during a review pass.
It's a major risk.
That could lead to completely incomplete analysis, flawed advice, or even expose clients to massive unforeseen risks.
Are developers working on ways around this, like ways to effectively slide the window or maybe summarize preceding text to feed into the current window?
Yes, techniques like sliding windows, retrieval augmented generation, RAG, which pulls relevant snippets into the context, and developing models with much larger context windows are all active areas of research and development precisely because this is such a critical bottleneck.
What a journey that was
Oh.
through the core foundations of legal AI. Feels like we've covered a lot of ground from the really broad strokes of artificial intelligence and machine learning, down through the nuanced architecture of things like neural networks, the creative power of generative AI, and then into the really nitty-gritty limitations like tokenization and context windows. Hopefully, you listening feel better equipped now with a deeper understanding.
Absolutely. And if we connect all this back to the bigger picture, you know, knowing these terms isn't just about sounding smart in a meeting. It's really about being equipped to make critical decisions.
Right.
It's about mitigating very real risks and truly leveraging AI effectively. Whether you're a lawyer advising clients on adopting new tech, or maybe a business leader evaluating AI tools for your company, or frankly, just anyone navigating an increasingly AI-driven world, this understanding is becoming invaluable. It helps you look past the marketing sizzle, as they
That's
say.
actual stake. Yeah.
Okay.
Couldn't agree more. You're now better prepared, hopefully, to navigate this rapidly evolving AI landscape, to ask the truly incisive questions of vendors, of developers.
And importantly, to spot that crucial difference between slick marketing fluff and genuine, capable, but maybe limited technology. That empowerment lets you use these powerful tools wisely, strategically,
Yeah.
and safely.
And maybe this raises a final important question for all of us to think about. As these AI systems become more and more deeply integrated into our daily lives, our professional tools, especially thinking about those black box issues we discussed, what new responsibilities do we as the users, the developers, the shapers of these technologies, what responsibilities do we collectively bear to ensure that their outcomes are not just efficient, but also somehow auditable, reliable, fair, and transparent?
That's a profound thought to leave us with. It really highlights the ongoing, maybe even increasing human role and responsibility in this technological revolution. Thank you for joining us on this deep dive today. Keep learning, keep asking questions,
Keep questioning.
and we'll catch you next time.